All right, exciting day today because I'll bet we finally figure out what is wrong with this thing and get a fix even. So I am counting that this is going to be a problem with idle air control motor. I don't think the idle air control motor is not working. I believe that it is just not positioning correctly and consistently, which totally explains every symptom that we've seen so far. So true to the new direction that I promised in the channel, I'm not going to break off to the dry erase board and go into detail on the idle air control motor, also called an IAC. We'll save that for a separate video. It'll be diagnosis and understanding the idle air control motor, where I go into all detail about its operation, how you would test it with and without a scan tool, all that. But because of the direct relevance, really briefly, an idle air control motor is basically a little motor that controls the amount of airflow that bypasses the throttle plate. And in later model cars, it actually changes the throttle plate itself. But on this model, there's going to be, when the throttle plate is closed, when you are off the pedal, there is going to be a bypass, an air passageway that this idle air control motor either opens or closes to certain degrees to allow air into the engine. The idea is when you are off the accelerator pedal, the throttle plate is closed, you still need air coming into the engine for it to run, obviously. And there's sources for this, like, there's some from the positive crankcase ventilation and things like that. But you need a metered and controlled source of this fresh air so that you can adapt to different load changes under idle. So the idea is, as was observed earlier, when I turned on the air conditioner, the fuel trims shot through the roof. Well, one explanation for this is because when you turn on an air conditioner, especially if you're at idle, that's an additional load on the engine. The idle air control motor has to open. If it's not open properly, then the problem is you'll have more air coming in than what is anticipated, causes a lean condition. The other thing too is you might be thinking, well, wait a minute, you get these lean conditions when you're under load, and why would you need an idle air control to open when the engine is under load, when the throttle plates are open? And you actually don't. The idle air control motor does not open when the throttle plate is open because it needs to. It is opening when the throttle plate is opening because it is predicting that at some point that throttle plate is going to have to close while the engine is under a different load than it would be if the engine were idling. For example, if you're accelerating and then you let off the pedal, that's a whole different thing than just sitting in an idle. So the idle air control motor is sort of predicting a position for when you let off the pedal. If it is not opening as predicted, then of course more airflow is coming in than what would be predicted by the PCM lean condition. As we've seen various times, we've been at very high fuel trims at idle and perfectly normal fuel trims at idle. This is basically, to me, indicating different positions of that idle air control motor because it is inconsistent. And we're going to prove that very easily by hooking up the scan tool and looking at IAC position. Now, one thing, I did notice that on my AutoIngenuity generic parameters, there is no selection that I have for idle air control motor. Thus the reason in the previous video I wanted to validate that I am getting accurate fuel trim data, at least consistent fuel trim data I should say, in enhanced mode, because I have to have enhanced mode to look at my IAC position. So it all comes together now. But let's go ahead and get the scan tool hooked up and see if we can find a correlation with IAC position and this fuel trim issue. Let's go ahead and get AutoIngenuity up here. I need to get into enhanced parameter mode in order to get IAC readings, which is a little unfortunate, being that I don't trust enhanced parameters nearly as much as I used to, but we don't really have a choice here. Let's make sure. Okay, so one of the things I want to do first is I need to make sure that I did clear those codes for the misfires that I intentionally caused when I was determining the bank-specific variables to get this far in the first place. So let's go ahead and do that real quick. I just need to check on this mode here. And we have good. I did clear them, so we should be good to go here. So one of the things, let's see, one thing I want to do, this is a problem. What I want is map math of course, idle air control and then both fuel trims, but I can only put 4 things at a time up here. And the idea being, of course, that when we see the fuel trim change, we'll see change from the idle air control motor and the map, but no change from the MAF, because of course the idle air control change would not be affecting the MAF. And that's what I wanted to show. And I could put them on different graphs, but the trouble is that it doesn't continually update between graphs. So I really need to get everything on one graph. You know, one thing actually I need to do is validate that the map sensor works, because remember, I do not know we have an idle air control problem. I just strongly suspect it, but we haven't ruled out map and MAF yet. So let's get map pressure volts. Here's pressure 1. Let's do that. And we've got 12. Whoa. Oh, no, this is in PSI. Okay, geez, good. So let me think here real quick. It's going to be 14.7 pounds per inch at an atmosphere. So this is actually right, because I live in Denver. And actually, I'm at a higher elevation than the city itself. So this is dead on. All right, well, that was a panic moment. I thought that maybe my philosophy was mistaken. And we're going to see that drop dramatically if I start the car. Let me actually go ahead and do that just to be sure. Okay, and it does drop considerably. And I'm kind of more of a voltage person here, because that kind of freaks me out. I was expecting inches of mercury or something. Let's look at the voltage. It should be under a volt, and it is under a volt. We're at 0.9 volts, so that's good. Let me go ahead and turn the engine off and just make sure that we go back to approximately 3.5 volts or whatever. Okay, and it's about 3.89 volts. Good, perfect. So our map sensor works. That's, as a matter of fact, another one off the list. Yay! Okay, so what I am going to do is, let's of course put idle air control on there. What do we have for that? We've just got idle air control position. And why is it showing way down at the bottom? Because the counts are like at 70,000. Why is it defaulting to that? And the position is at 123, so we should certainly see that change when we start the engine. Okay, so it does change, and it is, where is it at? 74. Let me go ahead and bring up long-term fuel trim, and I'm going to actually change the scales on these long-term fuel trims so that any differences show up a little bit better. And the idle air control motor is still bottomed out there because of the scale. I forgot I wanted to change that scale. Let's put 500 there, because I think that on a GM an idle air control goes from 0 to 250 counts, I think. I'll have to definitely research that before I do a video on it. But there, so now it's brought up a little bit better. And then, that's all right, it's sitting right on top of my map. So we got long-term fuel trim, bank 1 at a 0 to 50 scale. So now we need long-term fuel trim, bank 2. And I took too long doing this. I just heard the car go into closed loop. So anyway, let's see where we're at. So let's see, our long-term fuel trims are on top of each other at about 3. Now, wait a minute. Okay, so again, we've got another difference there. Normally, when I've got out of open loop and into closed loop, we would have very high fuel trims that improve with throttle. So let's see what happens if we had throttle now. Okay, so long-term fuel trims are in green and orange. We see they increase slightly under throttle. We've got the map, of course, increases, and the idle air control, of course, increases. As I stated before, it's going to open. And let's see here. Let me do this. One thing we know is pretty consistent. If I turn on the air conditioner, those fuel trims should shoot up like over 20. So let's do that. All right, so air conditioner on, and the fuel trims really didn't increase. Now you notice the idle air control motor position increases, which we would expect, but it seems awful high. And of course, we've got an increase in the map, presumably as a result of the idle air control motor opening. But now I'm not getting increase in fuel trim. So now we've got another thing that's different. What the hell? What in the hell? Seriously. We can see we get improvement in the fuel trims. Fuel trims are in green and orange. Now, how come I didn't get a change on that last throttle blip too? All right, more variability. Awesome. And now I'm also, of course, wondering, is this because we're in enhanced mode? But I would like those fuel trims to be high right now, like around 20. And all they do is improve with throttle now. God, why is it every time I try to make a simple video, things always go awry like this? And why is the idle air position totally different now, despite the fact that there's not that much change in the fuel trims there? All right, first let me turn off that air conditioner, see what happens. So the air conditioner, we lower our fuel trims just a bit. Pretty dramatic decrease in idle air. It drops the map. Why is this not behaving the same? All right, let me, I guess I'll have, maybe if I drive the car around a little bit. Why is the idle air control kind of high, but we still have, it doesn't seem proportionate with these fuel trim changes to me. Is this a generic mode thing, or, you know what? Let me do this. Let me see if those fuel trims are actually accurate. Here we go again. Let's connect up in generic mode and see what I can pull up. God, I'll tell you, the adventures of... The one thing that's been consistent is the type of inconsistency until today. All right, let me just quickly pull up long-term. Actually, let's just go here. Live data meter. Oh, the long-term fuel trims are the same. Let's see if what I've got for an idle. See, I don't have any idle air control on generic mode. Let's just check that the map is good. Yep. Well, okay, so those fuel trims do seem correct. Let's see what happens with them. They improve slightly with throttle. Let me try turning the air conditioner on now that we're in generic mode. All right, air conditioner on. This should send these fuel trims through the roof, and it does not. And why did my map not change when I turned on the air conditioning? My map, I would have expected to go up more. What the hell? All right, let me try something else. Let me get out of here and let's look at that idle air control thing again. God, I thought curing cancer was hard. This doesn't hold a candle to fixing a frickin' car, I swear to God. All right, let me just make sure we got no errors or anything still. I know we don't. No errors across the board. So let's see. Let's bring up that idle air control motor position. What I want is a desired idle position. Let's see if I've got that. EGR, there's a desired airspeed our idle airspeed, that is not going to help me. What is that? Oh, that's desired idle speed. That's not what I want. Where was that? Desired airflow. That's what I want. 0.71 pounds. Well, that's useless to me unless I have some baseline to compare to with the actual airflow, or if I have a conversion with this and the position. So that doesn't help me at all. Okay. All right, let me, why does it keep defaulting to this incredibly high count rate like that too? That's kind of aggravating. All right, so it looks like, all right, let's bring up long-term fuel trims 1 and 2. And over here, let's get some oxygen sensors here. Just make sure we're cycling. So those are good. Okay, so our long and short-term fuel trims are overlapped exactly. Let's see. They drop. Now let's see where our idle air is. So it's at 54 with the fuel trims at 6. Then let me try turning that air conditioning on one more time. Where's our map sensor? I forgot our map sensor. All right, where's our map sensor volts? In blue. See, the map sensor should still be high, shouldn't it, if that idle air control motor isn't closed yet? That doesn't look very proportionate, does it? You know what? I wonder if this, we're in enhanced mode here. I wonder if this is one of those flippin' substituted values. Let me unplug this idle air control motor. Oh, wow. Okay, so I unplug the idle air control motor, plug it back in. There is no change either on the scan tool or on the idle, which is a bad sign. And as a matter of fact, I'll bet if I hit the throttle that the idle air control in red is going to increase despite the fact that it is unplugged right now. And it does. So how is it increasing if it's unplugged unless I've got some kind of substituted value? Notice the idle air control position is dropping. So this is a call, I believe, for the position, but it is not reflective at all of the actual position because it is not plugged in. Let me go ahead and plug it in and see if there's any change. Notice the IAC position is really low now, but it's not affecting the fuel trim or the map. So this IAC is dead. Now, is the IAC bad or is it just not getting voltage? That's the question now. All right, so let's get this IAC out of here and see if it's moving. One of the things I'm thinking, if there's an electrical issue here, I wonder if it's possible the electrical issue could also explain my variability with the enhanced parameter and the failure to get bank 2 and stuff like that. I do wonder. Normally I would never hope for an electrical issue over just a bad motor here, but if it explains my problems with that long-term fuel trim on bank 2, on my enhanced parameter mode, that would be pretty welcome. Hopefully it'll be both. Maybe the electrical problem is inside the motor causing that, but we will find out. All right, so if I had a manly scan tool, I would be able to plug this thing in and command this thing to open and close to certain positions and witness that it actually happens. As a matter of fact, that would have been very handy to do inside the car. I do have some communication ability bidirectionally with Auto Ingenuity, but certainly I know I don't have any ability to do an IAC like this. All right, so what I am going to do in my unorthodox manner as usual is unscrew this just about all the way. And then I made a little plug here with a handle on it so I can recover it. I'm going to plug in that idle air control orifice there and then start the car, and hopefully the car will run. I think it will. But what's going to happen is with that completely closed, the car is going to be starved for air, and it is going to want very badly to open or pull back that pintle, as will be shown on the scan tool. And when I plug this in, we can see if the motor moves or not. So that's the plan, at least. A little convoluted, maybe. Pretty interesting video. You're damn right it is. All right, let's give this a try. All right, so the car's barely idling. Let's go ahead and plug this guy in. And I can actually feel it pulling back a little, but it's very choppy. And it's actually not pulling back. Well, it is pulling back a little, and now it's totally stopped. Well, that's because we lost our command in red. The red light, of course, was IAC. But that was not a very promising response at all. But it does pull back. I was a little worried because if it didn't pull back at all, then I wouldn't be getting, it wouldn't have a lean condition, I guess. If anything, we'd be running a little rich because less air would be coming in than anticipated. But that is definitely not a good response. All right, I just want to try this one more time, and I removed the spring there so there'd be a little less resistance on it coming back, just to see if the motor's just really, really weak. But the fact that I did feel it move indicates that there's signal, but is the signal consistent? But let me just try this one more time. All right, so let's try that again. This thing should start pulling back now. There goes our red line on the bottom, and it is drawing back, but I can actually count about a pulse every half second. It's really not drawing back. It hasn't moved, and you can see the call there. Actually, it has moved just a little, but I mean, this would take an hour for it to draw all the way back at this rate. We can see we still have our red line call there. And wow, you can just feel a pulse about every second right now. So yeah, this motor, it does move a little bit, but it's definitely not responsive. Now, we just confirmed that this valve is not going to open. It's not going to pull back based on that idle test. But what I want to do now is the reverse of that. What I want to do is see if the command for the closing of the valve works. So I'm going to screw this thing in all the way. And I'm going to go ahead and plug it in. And we'll put it here so that you can see it. And what I'm going to do is use my little stopper, and I'm going to open that hole to allow more air in. Once I get a high enough idle, this red line representing the idle position, and by the way, it's 310 counts, so I was wrong earlier, about 250, I guess. But anyway, that is going to want to drop and open this valve. In other words, it's going to want to extend this pintle. That would, of course, block the hole more. So let's see if that command works. We've already confirmed that it won't draw back, but let's see if it goes the other way. All right, so there's a pretty good leak. We should see the red line decreasing. And I can feel that it's working. Watch the pintle. The pintle is moving out. All right, and I don't want it to fly off or anything, but okay, so that gives us some information right there. Don't you just love that feeling when you know you're on the right track? And we definitely are. So, and can you imagine, by the way, if a parts changer had this car, what hundreds, if not thousands of dollars might have gone into it. I mean, here on a channel dedicated to not doing parts changing, and we didn't change any parts, if you notice, by the way, through this whole thing, but we did come within a hair of replacing a PCM. And we still might, actually, because we don't know that there isn't control for opening this valve. So what do we know? Well, from those tests, which admitted I was pushing my luck a little bit, and we're going to be a little safer here from now on by directly applying current to this motor to test it. We know there's commands to open it from the computer, but is there no electrical command reaching the motor, or is the motor not functioning? So that is where we are at right now. What I need is a wiring diagram to look and see which terminals here will be the ones that control the motor retraction, and then we'll put 12 volts to it and see what happens. All right, well, once again, a change in plan. Nothing on this video is going to be easy, but I did find a diagram here, even better than a wiring diagram, actually. It is for the actual connectors. And the problem is this is not your typical electrical connection with the power and ground. I actually do not know how you would be expected to operate that motor independently of the connector in the car. So they must have some way that you would do this at a dealership or something, I imagine, but it's not like I'm just going to be able to put a ground and a power and extend the pintle and then a power and a ground and retract the pintle. It's not going to work like that. So anyway, let's go to plan B. All right, well, I cannot catch a break on this whole case study, I swear. But I'm trying to find if there's any way that I can test this IAC valve by putting voltage directly to it. And as far as I'm seeing, there really isn't any way to do that without this sort of special equipment that seems it would only be available at a dealer or something. The best I got so far is actually from Yahoo Answers, where a guy states that you have a bad IAC if your car idles high for no reason. Oh, well, there you go.